Today's lesson is going to cover graphing with vertex form, which is another approach to graphing with parabolas. In Learning Target 2, we talked about graphing with parabolas using roots, axis of symmetry, and a vertex. But there's another approach to doing this. So today's EQ is, how do you graph a parabola from a quadratic in vertex form? This is what vertex form looks like. Vertex form is y equals a times x minus h squared plus k. A, H, and K are all numbers, and of course we'll have X and Y in the square in all of our problems. To figure out what each of these things are and how they affect the way that parabolas look, let's switch over to Desmos and take a look at some possibilities. Desmos is an online calculator that graphs, but one great feature is that we can actually bring up these manipulatable tools that help us explore properties in algebra. So up in the corner, you see that we have a y equals a times x minus h squared plus k, so that's vertex form, and it gives us these sliders. So we can actually use these sliders to help see what happens to the graph. So right now, our a is 1, our h is 1, and our k is 0. So let's move these sliders to see what happens. As I move the a slider, the number in front of the parentheses, I see that it just causes the parabola to get skinnier and skinnier as those numbers get bigger. So if the numbers are bigger than 1, it gets narrower and narrower. If I go less than 1, it's now getting wider and wider. But if the a becomes negative, the parabola flips over. So again, if it's bigger than 1, it gets narrower. If it's smaller than 1, it gets wider. But if it goes into the negative, it flips upside down, but can be narrow or wide as well, negative. Okay, let's get this back to 1. Now let's take a look at the h. Let's see what the h does. As I move the h to the right, it moves the parabola to the right. As I move the h to the left, it moves the parabola to the left. So when there is a positive number, it goes to the right. And when I plug in a negative number, it goes to the left. But be mindful that this negative 4, when plugged into the equation, would actually say plus 4 because of the vertex form's negative. So let's get this guy back to 1. Now let's try to manipulate the k. The k, when the k increases and becomes bigger than 1, it moves it up. As it decreases and becomes negative, it moves it down. So k is a shift of going up and down. H is a shift going left and right. And a is a widening and narrowing or a flipping of a parabola. All right, let's add in some pieces to this. Our a actually causes our parabolas to become wide or narrow. Our h moves things left and right. And our k moves up and down. But more importantly, the reason why this is called vertex form is because the h and the k are actually my vertex. Here's a couple of examples. Let's talk about what is happening in each of these examples and what kind of shift it's been done to it. In this problem, y equals negative x plus 2 squared plus 4, I notice that there is a negative sign. So this parabola is flipped. So it points down. There's no number in front, so it's no wider or narrower than a normal x squared. There is a shift in the x and the h. Remember, there's a negative in the formula, so when I have a positive 2, it's actually a negative 2 that was plugged in because 2 negatives make a positive. So this actually means left 2, but this 4 is just normal 4, so this means up 4. And our vertex which would be found at h comma k, -2, 4. At our second example, y equals 2 times x minus 3 squared minus 1, we do have a number right here. So this parabola does point up for positive, but because it's a 2, it's made it narrower. Remember, large numbers make a parabola more and more narrow. This has a 3 next to the x minus, so this is right 3. And we have a -1, so this means down 1. And our vertex in this is a +3 and a -1. You're going to have to get used to the fact that normally it's minus h and plus k. So consider that these signs don't always mean exactly what you think they mean. Remember that two negatives will make a positive inside the parentheses. Now, how would you write an equation in that form if it wasn't already there? We do this by completing the square. To complete the square with all the pieces already on the left, what we're going to do is we're going to put this part in our parentheses. And the space I'm going to make is going to happen right here after the 8. I'm not going to put the 11 in there because he is not the perfect number to go along with 8. We also have a space after the 11. So what is our perfect square number that goes here in the C spot that's compatible with 8? 8 divided by 2 is 4, and 4 squared is 16. So I'm going to add 16 next to the 8. Now I can't technically change the 11. So if I'm adding 16 next to the 8, I actually have to take away 16 from the 11 because I'm not actually allowed to really change the numbers in this equation from what they are. So technically speaking, I'm not really adding anything because if I add a 16 and minus a 16, that's 0. But for sake of being able to complete the square, I'm going to put a 16 here, but a minus 16 outside of it, so that technically speaking, I'm not actually adding anything. When you factor out and write as a perfect square binomial, you get x minus 4 squared, and then negative 11 minus 16 would be negative 27. So now it's in vertex form, and I can see that I have a vertex at +4 and -27. Let's try to graph a parabola from a quadratic already in vertex form. Y equals x minus 4 squared plus 5. Well, the nice thing about having vertex form is there's no real work you have to do to find the vertex. So our vertex is at a +4 and a +5. H is 4, K is 5. We don't have a sign change, so the 4 is positive, and it's a +5, so it's +5. So let's go ahead and plot that. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right there. Remember, the axis of symmetry does go through the vertex, so we can draw our axis of symmetry down through the vertex like that. But now we need to find some other points for our parabola. Now, one thing that I notice is this is not factored. Since the quadratic is not factored, I don't know my roots, but I can find some other easy points. How about we try plugging in 1, 2, 3 and find out where that hits? Y equals x3 minus 4 squared plus 5. So I get a -1 squared is 1, 1 plus 5 is 6. So my point is at 3, 6. Plugged in 3, got 6. So let's do that. 2, 4, 6. The nice thing about having an axis symmetry is I don't have to plug in another number to find a matching number on the other side. There we go. If I want to, I could also plug in a second number to get super accurate. How about I plug in 2 and find out where it hits up here? Two minus 4 is -2. -2 squared is 4, and 4 plus 5 is 9. So I plugged in 2 and I got 9. So there's another point for my parabola. 2, 4, 6, 8, 9. 2 spots to the left and 2 spots to the right, and now I can actually draw a really good looking parabola. So again, easily identify the vertex, plug in a couple of numbers, plot them, and match them on the other side of the axis of symmetry. So those are the only real steps for graphing with vertex form, though not all quadratics come looking like vertex form. If they do, here's an easy way to actually graph them. If you have questions, make sure you get them down into the left-hand column and share them when you come back into class. Don't forget to click forward and hit the submit button so that I get a record of you watching the video.